Hello students, this is Shachi. In today's session, we will learn about effect of change in concentration on chemical equilibrium with the help of Le Chatelier's principle. Students, first of all, we will see what is a chemical equilibrium. A chemical equilibrium represents a balance between a forward reaction and a backward reaction. And in most of the cases, this balance is quite delicate. So you must be thinking why it is delicate. The reason is that when we apply an external stress such as pressure, volume, temperature or concentration, the equilibrium will get disturbed and in order to restore the equilibrium, it will move in that direction where the effect of added external stress is opposed. So, it can move either in forward direction or it can move in backward direction. Students, we can predict the direction in which an equilibrium will proceed with the help of a principle which is called as Le Chatelier's principle. So now let's see what is Le Chatelier's principle. Students, according to Le Chatelier's principle, if an external stress, which may be pressure, temperature, concentration or volume, is applied to a system at chemical equilibrium, the equilibrium will get disturbed. And in order to restore the equilibrium, it will move in that direction where the effect of added external stress is opposed. Now, we will learn the effect of change in concentration on chemical equilibrium by taking few interesting experiments and we will explain the result with the help of Le Chatelier's principle. The experiment which we are going to discuss here is about the aqueous solution of iron thiocyanate. Students, when iron thiocyanate is dissolved in water, an equilibrium is formed and that equilibrium has been shown in beaker A. So what is there in beaker A? Beaker A consists of aqueous solution of iron thiocyanate in which following equilibrium exists. So you can see that iron thiocyanate on dissolution in water forms iron thiocyanate ion which is red in color and it is in equilibrium with ferric ion which are pale yellow and thiocyanate ions which are colorless. So this equilibrium exists in beaker A. Now we will learn what will happen if we change the concentration of products or the concentration of reactants. So first of all, we will see what will happen if we add some sodium thiocyanate in beaker A. Students, when we add some sodium thiocyanate in beaker A, then what will happen? Sodium thiocyanate on dissolution will provide sodium ion and thiocyanate ions. So now it's clear to you on addition of sodium thiocyanate in beaker A will increase the concentration of thiocyanate ions. So what will happen can be predicted with the help of Le Chatelier's principle. So according to Le Chatelier principle, the equilibrium will move in that direction where the effect of added thiocyanate ions is opposed. So what will happen? Thiocyanate ions will combine with ferric ion and they will form iron thiocyanate ions which are red in color. So as a result of which what will happen? The backward reaction will proceed and the color of solution becomes more red. Intensity of red color increases. So I hope it is clear to you. You can see here that equilibrium will proceed in the backward direction. Now, in the third case, we can add some ferric nitrate solution in beaker A. What is ferric nitrate? Ferric nitrate is FeNO3 taken thrice. Ferric nitrate on dissolution in water will form ferric ion and nitrate ions. Again, we can see that on addition of ferric nitrate in beaker A, the concentration of ferric ions will increase. So, the direction in which equilibrium will proceed can be predicted with the help of Le Chatelier's principle as the concentration of ferric ion is increased here. So, ferric ion will combine with thiocyanate ion and will form iron third thiocyanate ions, it means the reaction will proceed again in the backward direction and the intensity of red color will increase, which is shown here in beaker C. So in fourth case, we may add some oxalic acid to beaker A. Oxalic acid will provide oxalate ions. Oxalate ions are C2O4 2 minus. So oxalate ions combine with ferric ion and they form a stable complex, which is Fe C2O4 taken thrice, 3 negative charges. So this is a complex of oxalate ions with ferric ions. So again, the direction in which equilibrium will shift can be predicted with the help of Le Chatelier's principle, as by the addition of oxalic acid to beaker A is decreasing the concentration of ferric ion. So what will happen? More of the iron thiocyanate ions will dissociate to form more ferric ion. So we can say that a reaction will move in the forward direction. You can see that the reaction is shifting in the forward direction. So now we can conclude that if we increase the concentration of products, the equilibrium will move in backward direction. Or we can say that the reaction will move from right to left. Or if we decrease the concentration of products, the equilibrium will move from left to right, or we can say that forward reaction is favored. Students, I hope each and every point is clear to you. Thank you so much. Have a nice day.